Right. So welcome everyone to the last talk of the day and of the Sub0 conference. And now we have Liam from Parity, and he will be talking about how to safely perform runtime upgrades of the substrate-based chains, right? Yeah, so stage is yours. Thanks for coming.
Cool. Thank you so much. Hello, everyone. Thank you all for coming here. It's great to see so many people interested in runtime upgrades. Runtime upgrades. So yeah, just briefly, I'm Liam. I went through the PBA Cohort 2 in Buenos Aires earlier this year. Now I'm working on the Frame team. A big part of what I've been working on recently is runtime upgrade stuff to kind of make that whole process easier to do, harder to mess up. So this is also like a workshop format. So we have a whole 50 minutes, and rather than just being like a talk where I talk at you for 50 minutes, it's like this is it is encouraged for you guys to like code along with what I'm doing. Like we will be doing a bit of coding, we'll be looking at code and stuff like that. And so if you're interested, you can check out the slides, and that'll just make coding along a little bit easier. Otherwise, you can just follow along with me. And yeah, let's get started. But if you are following along, as you all know, compiling can take a little while. So I suggest that you kind of get compiling stuff in advance, so then by the time we get to actually doing stuff, you're not just sitting there kind of waiting. So the first thing that would be compiling, if you are following along, is the Asset Hub runtime. So we're going to be adding a new palette into the Asset Hub runtime, and then dry running a runtime upgrade on Polkadot Asset Hub. So if you don't have Polkadot SDK, you can git clone Polkadot SDK. And then you're going to want to check out this branch, Liam Migrations reference docs. So we are working on an example palette for runtime migrations right now, and kind of like some reference documentation for migrations. So there's one place that tells you everything you need to know about doing runtime migrations. That's on this branch right now. So yeah, you'll want to check that out if you are following along. Here we are. So we've got migrations. In the storage migrations, so this is the palette, by the way. Very simple. We've got a storage version. We have our, where's our storage? Oh, here it is. Here's our value, and here's our call. So it's a very, very small palette. So we've created this migrations directory. We're making it a module. We're exporting v1. So like a pattern we've been using at Parity for quite some time that is working quite well. And I would recommend it. I think it's pretty good. You have this migrations directory. You make that a module, and then you export another module for each migration that you want to write. So for example, we have this module v1 that is for migrating to v1, right? And then if we wanted to make a new migration later, we're going to make a new module called v2. And then we can kind of have all those nice structured, nice and structured and organized. Now we're going to make even more modules inside v1. The first module we're going to define that almost every migration will need is an old module. And the reason that we need the old module, well, I guess it's kind of spoilers here, but we need to define a storage alias for the old value format. Because in the migration, we need to access value both in the old format and also the new format, right? And so we need to make this thing called a storage alias. That allows accessing on-chain palette storage that's no longer accessible via the palette. And so I'll show you what that looks like. If we go to old, we just take this storage alias. That's from frame support. And we can, now we have this old value, right? See, this is a U32. And so now this is going to allow us to access the old value under like old value, right? So if we want the new value, we run, I think it's like create value, old value, right? That's the first module that we've got. The next module is going to be the version unchecked module. And so here is where we're going to put all of our raw migration logic that's actually going to execute. It's actually going to like take our storage from v0 to v1. That's where like the most and also we're putting this in a private module because we don't actually want to use this logic directly in our runtimes. We want to use version controlled or version checked code in our actual runtimes themselves. So that's why we keep this module as private. And so we create this struct called migrate v0 to v1, which implements on runtime upgrade. Who knows what on runtime upgrade is? Pretty much everyone? OK, awesome. Who knows what like pre and post hooks are, like pre-upgrade and post-upgrade hooks are on runtime upgrade? OK, awesome. Some people a little bit like unsure. So I'll cover that like super briefly. So the main method exposed that you implement on runtime upgrade is on runtime upgrade. And so this method is literally what is called by the chain after you set the storage, and then in the next block, at the very beginning of the next block, on all of the on runtime upgrade code that is defined in your runtime is going to execute. So this is like the actual migration code. And then you have these two other hooks, pre-upgrade and post-upgrade. So these two hooks are feature-gated by the try-runtime feature. And so if you remember earlier when we compiled Asset Hub, we passed features try-runtime. And what that's done is it's built us a runtime with these extra hooks in them. And when we dry run our migration, what it's actually going to do is it's going to call pre-upgrade, then it's going to run on runtime upgrade, then it's going to run post-upgrade at the end. So we can kind of and in pre-upgrade and post-upgrade, we can assert that our migration actually succeeded using using on-chain data. We make sure that the dry run actually succeeded. This will make more sense when I show you the code. So let's take a look at the version unchecked code. I want to zoom in, not out. So we have this struct migrate v0 to v1. We're implementing on runtime upgrade. Let's look at on runtime upgrade first. This is really easy, quite simple. So yeah, we're reading the old value. If we have the old value, then we want to make the new value. We want to build the new struct, and we just want to put the new value in there. And then on runtime upgrade needs to return the weight that it used, right? So one read and one write. One for reading old value, one for writing new value. If there's no value there, we just return one read, and we don't really do anything. It's like a no-op. So that's what on runtime upgrade does. For this palette, in pre-upgrade and post-upgrade, what we kind of want to do is use those to make sure that this process happened correctly, right? If I just forgot to do that, or maybe I mixed up current or previous, or I just made some mistake, we want to make sure we're aware of that. And so one cool feature of pre-upgrade is that it can return some pre-upgrade value. So when we're dry running this, we can the value returned from pre-upgrade is available in post-upgrade, if that makes sense. So we can take the old value from pre-upgrade, and then in post-upgrade we can take that value, there was maybe an old value, and we can assert that the migration was successful, right? So we can match on maybe old value. If there was an old value, then the expected new value, right, is the current and is this, the current, and the previous is none because we don't know, there's no previous. And then we get the actual new value from the actual on-chain storage. So just a reminder, this is all happening only when we're dry running. This is just testing. This is not actually executed on-chain when you run it for real, but it helps us dry run using real state. We can use this ensure macro. It's kind of like assert, but instead of panicking, it will return a error variant on the result. But you can use it a little bit like assert. So that's all the pre-upgrade and the post-upgrades hooks do. We just make sure if there was an old value, the on-chain storage was updated correctly, and if there wasn't, then kind of nothing happened. The value, we didn't just set something by accident. Cool. Does anyone have any questions about this? Yes.
So with this pre and post upgrade, we can check for everything which the developer considers. But isn't it possible to automatically check for leaks in the sense that whatever has the palette prefix and is no longer accessible by the new palette? Do you have some ideas about that? How could we enhance this pre and post thing to look for common mistakes of storage leaks which are not cleaned up by the migration process?
There are probably try-state is the best way to deal with that. So and then I think there's a try-state a way using try-state to check for undecodable storage. So if you've accidentally left some hanging storage or something like that, it can check that. I don't know. I can't remember exactly how that process is done. There are ways to do that. But really, like, you want to be quite verbose, like, to programmatically check every single storage item has been updated correctly. Like, in the pre-upgrade, you have access to the pre-upgrade state, and you want to make a copy of that or do whatever you need to do to be able to check that the migration is successfully completed. Then in post-upgrade, you want to thoroughly check, like, programmatically, everything is now in the new expected format. Yeah, and this will be run using your real on-chain data. Yeah, I'm not sure if that it doesn't quite answer your question, but
well, I mean, the tri-state, I don't know. Maybe I have to look into that. Yeah.
Yeah. Tri-state is cool. I won't talk too much about it, but it lets you check storage invariance essentially. So you can basically make assertions about how your storage is laid out, and then it's like even if maybe there's a bug in one of your extrinsics, and it say like the total count, like the length that you have. I won't talk about tri-state right now. But yeah, I recommend checking it out. And docs are coming to make that easier as well soon. So yeah,
Thank you.
Another question?
Yeah, well, my question is actually a follow-up question. So how does tri-state somehow interact with the pre and post upgrade checks?
Well, you can have your you can configure your runtime to run the tri-state checks immediately after your upgrade to make sure that all of these kind of like assertions you've made about the layouts of your storage are correct. But it's a little bit different to like the actual process of just writing a storage migration. So, yeah.
So technically, a tri-state could be seen as at least a replacement or doing the same thing that a post-migration check could do? In a more general way?
Not quite. I won't talk too much about tri-state here. Tri-state generally just kind of sets up like invariants that you want to hold true about your storage layout, whereas this like pre and post upgrade are more concerned about just actually making sure that your data is migrated correctly. Like you could potentially do a migration that deleted all of your data, but then maybe tri-state doesn't care. 'Cause, like having no data is still valid data. Tri-state is more about saying like, say you have a counter for like the length of a vector or something like that, making sure that like the counter of the length of the vector actually is like there are the correct amount of items in that vector, kind of like to align with that storage, if that makes sense. Like your storage is all consistent. Cool. All right, so that's implementing on runtime upgrade. Finally, we're just going to look at some like unit tests really quickly. So it's definitely encouraged to write unit tests for your migrations, just to like make sure that all of your kind of like base cases are covered, and like your code paths are all covered and everything. You don't miss any silly stuff, because as developers just always assume that you've got buggy code. So yeah, this is quite simple. We just have like two tests. One that handles no value. We call pre-upgrade and we get like the bytes from pre-upgrade. We execute and we get the weight. We assert that post-upgrade is okay, that it doesn't return an error. We assert that the weight is what we expected, and we also assert that like the actual storage is correct. So you can imagine like in a more complex upgrade, like this could get quite complex. But yeah, you want to kind of essentially, I think I have some notes up here. Yeah, you want to make sure on runtime upgrade returns the expected weight. That's very important for later, which we'll talk about. You want to make sure post upgrade succeeds, and you want to make sure that the storage is in the expected state. Given some base cases. Okay, and then we have the only public module in our migration, which is just called versioned. And yeah, it was kind of spoilers, but yeah, who knows why we need versioned? Who wants to like volunteer to chat about it? Anyone? Okay, that's fine. Yeah, let's think about this for a second. So we have this. Let's think about what would happen if we used version unchecked, migrate v0 to v1. Like that code would execute on chain, like when there's a runtime upgrade. But then, like, what happens if there was another runtime upgrade or something like that? You accidentally just like left your migration in there. Like, it would execute again. And also, we haven't solved our issue of the version mismatch between the current storage and the on-chain storage, because we didn't look at the on-chain storage at all in our migration. And so what people used to do, a previous pattern for dealing with this, is to kind of like write these these if statements in your migration that says kind of like, okay, get the on-chain version and then get the current version, and then like if the current version is this and the on-chain version is that, then execute it. Otherwise, do this. But that just became like quite like bug-prone boilerplate that you really don't want to mess up. And so we've abstracted the whole dealing with versions into this struct called versioned migration. Version migration is pretty easy to use. We'll look at the code in a second. But essentially what it does is it makes sure that, like, one, the migration only runs once when the on-chain storage version is 0. So your migration is only ever going to run once, which is good, when it needs to be upgraded. It's also going to check that it's going to handle updating the on-chain storage version to 1 after your migration has executed. So we're not going to have that like current version, on-chain version mismatch. And it's also going to handle like adding the any reads and writes from checking and updating the storage version into the final weight returned by your runtime upgrade, which is like these are small weights, but it's still it's still good to have correct weights returned from your upgrade. So like rather than looking at the docs for this, I'm just going to show you the example from here. So if we go to versioned, the way you use version migration is pretty straightforward. So notice we have this pub mod versioned, and we also write a migrate v0 to v1 in here, and we pull in, it's from frame support migrations, version migration. It takes, how many is that? 5 type parameters. The first one is the version that it will execute at. So the migration will only execute when the on-chain version is 0. What version is it going to? It's going to 1. So the on-chain version will be set to 1 after the migration is complete. Then you pass your migration in there. You pass the palette in there. And you pass like which DB weight. Is it Parity DB or Rocks DB or whatever that your runtime is using. And this is the migration that you put in your runtime. This is the only, see, this is the public, unversioned is not public. Cool. Anyone have any questions about version migration? Yep.
After a runtime upgrade, the storage version goes back to 0, or it stays on the one that you decide, and so the next migration you have to look at which one it is now and then add 1 to that?
Yes, correct. It will stay at 1. So we've now...
next one I'll say 1, 2, and next migration I'll put 2, 3, and like that.
Yeah, okay. Exactly. So like, if you want to make a new one, like if you wanted to update this palette, say you wanted to like add something, maybe, I don't know, maybe you wanted to make this like, I don't know if a U64 is the correct answer, but I don't know, you want to make this a result. Wait, no, that also would be the same on-chain. Say you want to like add a new thing in here, like you want to do some kind of thing, and this is like, I don't know, some. Right? Like you want to add something onto here. You would be like, all right, I've just changed the storage layout, so I need to I need to make a new migration. And so I'll check. Okay, what's the storage version now? It's 1. I want to update this to 2. And now, because I've changed the current version to 2, the on-chain storage is 1. I need to make a new migration in here. So I'll make a new v2 here, and I will execute v1 to v2 in my runtime. Cool. Let's remove that. Sweet. So scheduling migration to run. Yeah, so just like a note on this as well, it's like, oh yeah, standalone struct or palette hook.
One more question.
Oh yes, sure.
Yeah, if you fuck up the migration, is there like is there a rollback? Like, okay, let's go back to the previous state.
I mean, the short answer is like no. It has to succeed. Your migrations must succeed.
Okay.
The long answer is like there's ways to get around it, but it's very, 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 very bad. And so you should like never try to do something.
You should dry run it and be super sure it's.
Yeah, you need to really, really make sure it works. And try-runtime-cli will kind of help you make sure with a lot more confidence that it will work. You can never be 100%, and it's obviously there will always be some instances of things going wrong. And we will talk about, like, there's this forum post, people discussing, like, how do we improve the process for recovering brick parachains. I have, like, a link in the slides at the very end. But yeah, the short answer is just, like, it shouldn't fail. Like, there is no escape hatch. It's like your migration must execute. Got another couple of questions?
Yeah, hey, it's Mauricio. So one thing is, as you know, while actually building a palette or something, and you change some storage items or structure and everything, uh, it's kind of hard to keep track of everything. Maybe you miss something, right? Is there any tools whereby you can actually inspect while, like, okay, maybe I missed something to test in the migration before?
Pre and post hook, pre-upgrade and post-upgrade hooks. So you should programmatically check everything.
Yeah. But pre and post upgrade, like you do them manually. I'm speaking about, for example, a tool whereby you can inspect in a way, like inspect, like maybe in this struct, in this version it was like this, and now there's some error while encoding. So maybe you should check on the pre and post upgrade hook.
Yeah, I mean, I guess if you want to do, there is a way to do, like, check for the undercodable storage. I don't remember exactly what it is off the top of my head right now. There is a way to do that. Maybe there's a tool called Chopsticks. Which can help with that sort of thing. Chopsticks is great. I don't know if Brian is here. No? Oh, okay. Well, Brian's cool. He built Chopsticks. But yeah, okay. And one more, yeah.
Well, in one particular case, a migration problem was that the migration didn't complete within the block time.
Yes.
Will you go into strategies about that? Okay,
yes,
thank you.
absolutely. That is what we're covering next, actually. Well, yeah, we're going to add this to Asset Hub, and then after that, yeah, we have, my migration unit test passed, so it should be safe, right? No. You need, absolutely not. You need to dry run it using real state, and you need to make sure that your state can't be kind of like messed with, basically, to make sure the POV for the upgrade or the ref time for the upgrade isn't like too large. Yeah, let's continue. Let's add the example palette and migration to Asset Hub. All right, so I don't think many people are following along, and I do actually just have like a git pop stash. I'm just gonna like do this really. All right, I got something going on. What's this? That's fine. Git pop stash. Let's try this. Okay, cool. So this code essentially adds our new palette to Asset Hub. Yeah, we've added. We will cover that in a second. But first, we're going to add it to Asset Hub, and then we're actually going to dry run an Asset Hub runtime upgrade, and we're going to look at the POV size and the ref time that was used. We're adding the palette example storage to the Asset Hub Polkadot dependencies. We're adding the palette to Asset Hub. Let's just imagine that this example palette has always existed in Asset Hub, and it has some v0 value. Like, obviously, if you add a new palette to a runtime, it doesn't make sense to write a migration for it, because there's no storage there. But let's just imagine, for this example's sake, that the example palette has existed while it was v0. Implement the config. And then also we pass the migration that we wrote, palette, example, storage, migrations, v1, versioned, the versioned one, migrate v0 to v1. We pass it to this migrations tuple. And this migrations tuple is passed to the executive palette. And it is the executive palette which will execute all of the runtime upgrades in this tuple after there has been a runtime upgrade. Cool. Yes, question?
Yeah, I have a question regarding adding a new palette. You just said that you don't need a migration, but actually there was a problem also in some chains that if you deploy a palette that has a storage version that is greater than 0, it's not automatically written into storage. So you actually do need the migration also for first-time deployment of palettes.
Yes.
And my question is, has that been fixed, or do you still need a migration if you add a new palette that has a storage version greater than 0?
There is an open PR to address that. So yeah, there is a bug currently. I'll call it a bug, where it's like if you add a palette after Genesis, it doesn't set the on-chain version to the current storage version. That will be fixed very, very soon. There's a PR. It needs some refactoring, but it will be fixed. So don't need to worry about that.
Okay, so does that I guess that happens behind the scenes? It's completely invisible from the developer. So is that something that somehow could go wrong into the lack of clarity of what's going on, right?
Yeah, I mean,
it's only one storage write, so it's not probably a big deal. But let's say you have 200 palettes and it's 200 storage writes, and you don't know that there is such a weight because you don't see that.
That's a good question. I think it should be okay. That weight, I need to think about if that weight could ever become problematic. My gut says no, it should be fine. It's like the reading and writing those storage values is like so low, and also like it shouldn't matter too much. But it's a good consideration to bring up. Yeah. And yeah, also like in terms of people knowing it, it's like docs. Docs is the way forward here. Like we're writing reference docs for migration, so like this will just be something that will be documented. We got another question?
Yeah, I want to know why. So when we add the migrations to the executive type, we are basically, instead of the on runtime upgrade, we are shifting the responsibility of deciding when which upgrade has to be applied to the developer who adds that. I'm wondering, why don't we go into the on runtime upgrade hook and implement a selector that looks, okay, if the storage version is dead, we have to apply that migration, because it seems to me as this would save the migration system from the human fault of just forgetting a migration.
Yeah, no, that's an excellent question. So I think the question here, correct me if I'm wrong, is like, why did we define a standalone migration in like a separate module instead of implementing on runtime upgrade in the palette hook, right? Is that correct? Yeah. Yeah. So. Yeah, so the reason for this, and it's like at Parity, we've been moving more and more to using these standalone migrations versus the palette hook upgrades. I have a note about that in the reference docs, actually. Standalone instructor or palette hook. Yeah, so basically the reason is like, imagine if you're building a parachain and you have like version 1 of a palette, and then like maybe that palette goes through some iterations, like it goes through like 3 iterations, and now it's on version 4, and then you kind of like you upgrade substrate. And it's like, are we gonna, do we store every single migration that's ever occurred for a palette kind of like as part of that palette code? Like, that would be included in like the WASM blob, and like, it just kind of bloats things, and it's like and most people won't need it. And so, yeah, rather than using those palette hooks for these types of like storage migrations, like a pattern that we've been using more and is like recommended now is to make them standalone. So it's like, the developer of the parachain knows what is my on-chain storage and what is the current storage, and they can selectively apply the migrations where they need it. And also, like the try-runtime tool, which we'll see soon, will help you kind of like hold your hand to make sure that you don't mess up. Like make sure that you included all of the migrations that you need. And if you missed one, it'll be like, hey, it looks like you've missed a migration for this palette. Maybe you want to include it. Cool. Awesome. That's a really excellent question, though. Yeah, and so yeah, the palette hooks are still there. Palette hooks are still there, but for these storage migrations, recommend the other one. Yep. Another question?
Yeah, just to chime in on this point. So it would also be non-transparent to the runtime developer that a lot of migrations are running. So like it's similar to the point before, but if you have 10 palettes, and like they all have a lot of upgrades, and now the parachain developer just upgrades his chain. Now suddenly it produces an overweight block because all of the palettes are doing a lot of migrations that he wasn't aware of. So by listing them explicitly in the tuple, you like see that this will run.
Cool. Yeah. Thank you, Oliver. Great. All right. So let's go back to slides. We've added the example palette to Asset Hub. Why can't we just deploy now? We've got our unit tests. What we're also going to do is we're going to build our runtime. So let's run cargo build Asset Hub Polkadot runtime. Yeah, I mean, once we have our runtime, we've got the WASM blob. Why can't we just deploy it, right? Like it was touched on earlier. But yeah, it's basically like the answer is because we want to dry run the runtime upgrade using real storage. And this is really important for, I guess, like 3 main reasons. Like 1, we want to estimate the POV size. Like we want to make sure that we're not touching like 1 million storage keys, like under, which is going to produce a POV that the relay chain just won't accept, and that'll brick your chain because you'll never be able to produce any blocks. We want to estimate the execution time because this also, like if your execution time is too long, the relay chain won't accept your blocks. Your parachain is bricked. And sometimes like you just don't, sometimes it's just some edge case that you didn't consider, right? Like you write unit tests and you think that you've tested absolutely everything, but then it's like maybe you made a wrong assumption about the format of the storage, or there's some weird bug about like the sequence of the real storage, and your runtime panics like when you run it with like real storage. So it's really, really, really important, like must dry run your runtime upgrade using real storage, using try-runtime-cli. Some of you may be familiar with this. This used to be a subcommand on Substrate and also a subcommand, I think, on like all like nodes that were built. It's recently been picked up and moved into a standalone repository, and it's kind of like a standalone CLI now. And so yeah, let's dry run this. Let's dry run the upgrade using try-runtime-cli. So yeah, we've just built Asset Hub. And I have this command here, try-runtime. Try-runtime. Oh, let me zoom in a bit. And so what we're doing here, like when we ran cargo build earlier, it built the Asset Hub runtime in like target release, wbuild, Asset Hub polka.runtime, Asset Hub polka.runtime.wasm. So we're telling try-runtime-cli. Let me just like introduce. Wait, hold on. How many people are familiar with try-runtime and try-runtime-cli? Kinda, yeah. Most people. That's great. If you're not, like, the idea of try-runtime. Let me just like go to the docs really quickly. Background knowledge. So the basics of all the try-runtime commands are the same. You connect to a live node, or and scrape its state. So you get the real state, and then you put it inside this test externalities thing, which is kind of like a database that lives in memory. And then you call a specific runtime API, given the state you just scraped or you have stored using a snapshot, and the runtime. So the runtime is like our development runtime that we want to test, and we want to test it with the real state. So that's kind of like every try-runtime command does that. And the specific runtime API in this instance that we want to call into is on runtime upgrade, right? So the way that we use on runtime upgrade here is we say try runtime, we pass it the runtime that we want to use on runtime upgrade live. We give it the URL of a node. Good thing I'm connected to the Wi-Fi. I didn't really think about that. And so you can see now it's scraping the keys for Polkadot Asset Hub, and then it downloaded the values. You can see like, oh, okay, the original runtime that was on chain has this code hash. The runtime that we passed had a different code hash, so we basically just like ran all of the migrations using our new runtime, but the real state. And we can see like we're getting a log here. This is like some other runtime upgrade. This is some other migration that's running. And then we have our migration here, running example palette, versioned, that should say version migration, whatever, from version v0 to v1. And there were no errors or warnings, so it was successful. And you'll notice as well 2 logs that try-runtime-cli outputs is, OK, what was the POV size for what we just did? It was 3.2 kilobytes. But there's also a warning saying, hey, parachains, it's still your responsibility to verify that a POV of this size fits within your constraints. If this was like too large, this info would change into a warning to kind of like if in Kusama and Polkadot it's like approaching the threshold, this will change it to a warning. And there's also logs that consumed ref time, right? So by default, we're kind of assuming the max is 0.5 seconds, and so it's showing our ref time. So that's great. And we get this log saying, hey, try runtime on runtime upgrade. It executed without errors or wait safety warnings. But please note, it does not guarantee a successful runtime upgrade. You should always use recent state, and also make sure that there's no way that the state of your runtime could change drastically to the point where it's it succeeds now, but later maybe it could fail between testing it and actually executing it. And so I have something to finish. What we could do is show an example of what try runtime upgrade will log if you have something that's a bit dangerous or looks dangerous. So for example, in this instance, the code path that is run is this else statement, because there's no old value that exists. But if we imagine we had some weird, this should be U64. If you had if you did something bad and you're going to use a lot of reads or something like that, let's just show what that looks like. So we're going to rebuild our runtime again, because we need to build a new WASM blob with that change that we just made in on runtime upgrade. And let me just like turn off this low power mode. Yeah, absolutely. Yes, perfect.
Does the runtime CLI throws a warning if you're trying to use a WASM without the try runtime feature on?
We can do that and show you what will happen. It won't be a warning. It'll be more of a, oh crap, I just like tripped over and face planted. But yeah, it probably should be a warning instead. So yeah, we're scraping keys again. So yeah, there is a feature on try-runtime CLI, like the asset hub Polkadot has quite a small state, but for big chains like this takes quite a while. So there's a way you can like make a snapshot of the state that kind of loads in straight away. So if you do use this, I recommend try runtime create snapshot help to speed up your workflow. But yeah, we can see because we changed one of our upgrades to return like a huge ref time, right? We're saying like, all right, you're using like 300 billion or something like that % of what your maximum should be. So hey, you should probably like, please ensure this migration is not too computationally expensive, right? So we've got these like warnings now built into try runtime CLI, which should helpfully, if you run this on your chain with your real state, this should helpfully prevent most of the bricking type errors that have occurred this year. Like that style where it's like just the real state is too large. Still though, I want to reiterate something that's like written here in manipulating the POV size and execution time. Like it's still important to make sure your migrations like cannot be easily manipulated, right? Like don't iterate over a vector in like 3 nested for loops, that someone could just like add to cheaply, and then between you running the test and it looks good, someone adds a few storage items in there and now suddenly you're screwed. So just make sure that you kind of keep that in mind. Use bounded stuff, test bounded worst case scenarios. Yep. Question?
I just want to share one case I know of where even this was not enough, and the chain was bricked.
Yes.
So the problem is you are executing this on machine A, the try runtime thing, but then it is executed on the collator machine, which is not necessarily under your control, so you don't know what the performance metrics are. In that particular case, the problem was that the try runtime ran perfectly, but then the chain was bricked. And in the end, we found out that upgrading the collator to a more powerful machine actually saved the chain, and block production caught up again. So I guess you should make sure that you execute the try runtime on the weakest possible machine you have to live with.
So let me share some learning that I had about this recently. I had this question like while I was like adding this used ref time thing, which is very similar to what you mentioned. I was like, hold on, it's like if I do this on my Mac, the time that the runtime execution is going to take is going to be different from like the reference hardware. But the thing I learned about this ref time is it's actually computed. It's not actually computed based on how long it took to run. It's based on these dB weight read and writes that you use. And so someone else at Parity will be much better suited at discussing kind of like how these read and writes were, kind of how you convert these reads and writes into like a ref time estimation. I think it's like using the reference hardware that is there, and a whole bunch of benchmarking and stuff like that. But this consumed ref time will log the exact same value on every single machine. I'm not 100% sure. I'd love to speak to you afterwards more about this, but I would suspect that part of the issue that you encountered was because earlier versions of try runtime did not adequately notify you about how much ref time was actually used. Like you had to run it with debug logs, and then it came out with Yeah, or the benchmarks were bad. That could be it as well. But yeah, basically this should, yeah, now that it's correctly logging the ref time, this should hopefully fix that. But yeah, we can talk more after if you like. Cool. All right. What else we got here? Final thoughts. Safety tips. I think we've gone over the safety tips. It's like mostly just like don't put like, don't be easily manipulatable. Multi-block migrations are on the way. So like there might be some of you might have some questions like, what if I do actually genuinely just have like an active parachain with heaps of storage, like 1 million keys, and I just can't fit my migration into a single block? It is on the way. Our friend Oliver in the room is working on that as we speak. Yeah, the way multi-block migrations will kind of work is you'll implement a step function. You'll implement like a step function, and your migration will kind of like continue progressing with the weight that is provided to it. And if it doesn't finish in a block, that's totally cool. It'll just continue in the next block. And if it does finish, then you're done. So this should actually hopefully be like an even better developer experience, where as a developer, you don't need to worry if you're migrating 10 keys or 1 million keys. You just write it in a multi-block migration fashion, and it might take 1 block, it might take 100 blocks. Doesn't matter to you as a developer. So that's on the way. There is a GitHub issue tracking that. Another cool project, kind of like which you can also use for testing runtime upgrades, is Chopsticks, which I mentioned briefly earlier. Chopsticks will allow you to simulate your runtime upgrade occurring, and then kind of like have a development chain available on an RPC that you can kind of like connect to it with Polkadot.js apps, and you can inspect the state. You can like call extrinsics, and you can kind of like mess around manually with your chain post upgrade in like a simulated environment. So Chopsticks, like the way I kind of think about this, it's not like it's not a perfect way to describe it, but like Chopsticks is more for like manual testing, like just playing around with stuff. Whereas try-runtime-cli is more like programmatic, writing code to test things. And finally, this was also mentioned earlier, there is a discussion about parachain recovery techniques. So currently, parachain recovery is not great. Like it takes, I think, 28 days or something like that. If you do, shaking hands. Depends on approval. Okay, it could take a long time. It takes a long time. There's definitely ways to improve it. Thank you, Nathan. Cool. But yeah, I recommend checking out this thread. There's some interesting discussions on how there's ways to fix that. So yeah, that's all. Thank you. Thank you so much. And I think I saw a question off the back.
Yep. So thank you, Liam, for a really practical and useful talk, and also thank you to all of you for all the interesting questions that we had. So do we have any other? Yep.
Thank you for your talk. What do you guys think about the lazy upgrades?
Could you elaborate on lazy upgrading?
Like upgrade the storage as you need it.
Oh, I see. Yeah, lazy upgrades. I mean, generally, if you can do it, that's kind of nice. Like, I'm an advocate for lazy upgrades. This is more for like you can't lazy upgrade. But yeah, like lazy upgrading is essentially like as the storage items are accessed, you can migrate as you go, right?
Even for multi-block upgrades, you would need lazy upgrades because part of your state's going to be in the old state, part of it is going to be in the new state, so you have to take care of it anyway.
So the way Oliver can speak better to this, but I believe the way multi-block migrations are executed is like your chain goes into kind of like a restricted safe mode during the migration process. So like where like so then you don't need to have it being lazy. But yeah, generally, if you can write it lazily, I'd probably say do it lazily. It's just like nicer, it's much fewer things that can go wrong. Yeah.
Yep. Anyone else?
Oh yeah, absolutely. You say the repository. Oh well, I mean, you can check these slides out. Like Sub0 2023, liamslides.nlfi.app. You can take a photo if you want. And then all of the other links are just in there. So. Yes, absolutely. Yep.
All right. Thank
Thanks.
you, everyone.
Thank you, everyone.
This is it.